of course, it's time to start our next session. So, yes, I mean, dear participants, of course, the break time has been uh, much of it utilized in the right way for communicating with Dr. Mishra. And now we have our resource person for the next session, Dr. Vasudeva Murthy with us. And we'll be continuing with the session that we had yesterday, that was on Introduction to Indian Astronomy. So as we all are, though familiar with Dr. Rajat Vasudev, I'll just quickly read through Sir's introduction once again. Assistant Professor at the Department of ECE at BMS College of Engineering, Bangalore, PhD from Indian Institute of Science, Bangalore, B in Electronics and Communication from RVCE, worked at Amrita Vishwa Vidyapeeth, Bangalore campus, Pennsylvania State University, State College, USA, KTH Royal Institute of Technology, Stockholm, Sweden. Research interests mainly VLSI circuits and systems, but all that we are enriched with is Dr. Vasudev's passion about Indian knowledge system. So this is what is enriching us all the more. So with, of course, words of humble gratitude to Dr. Mishra and a very warm welcome to Dr. Vasudev. We are eagerly waiting for the next session on Introduction to Indian Astronomy. Over to you, Dr. Vasudev, so that we can begin with the session now. Welcome, Dr. Vasudev.
I hope I'm audible.
Yes, Dr. Vasudev, you're audible. Yes, clear and loud, Doctor.
Yeah, okay, great. See. Okay. Yeah, so please let me know if we can start. Yeah, so let me confirm that is my screen visible?
Yes, sir, your screen is visible.
Okay, great. All right. Okay, so should we get started? Any questions from last time? You're most welcome to ask.
Anyone willing to ask?
Morning, sir.
Yes, please go ahead.
So yes, that time we talk about that something, if we sleep in the north-south direction, maybe that is good for our brain.
Okay.
Sir said that, so I wanted to ask that it is written in our Vastu thing also that if we do so, like our brain is very positively affected. So should we believe in Vastu?
Well, I don't know much about it to comment. Okay, so maybe we can do it at a later time, right? So it is better we take the approach of science, right? So better we talk about architecture first and then go for this, right? Because Vastu anyhow is going to be a later concept. It was not there in the ancient time. So if we go in that order, when see, usually the most concrete and the most what should we say, the fundamental work will be the ones which are done in the ancient time. They will be the ones which are more core and essential to our culture. So whatever comes later on, we have to analyze it properly and then take. Okay, as a question of belief, it's a personal choice, right? I'm not here to say either believe or not believe. I'm here to tell you, try to understand. Okay, and then you can make up your mind whether you want to believe it or not.
Okay, sir. Thank you.
Yeah. Okay. All right. Oops. Okay. So yesterday we were talking about the motion of the sun, right? And then we said you could define the 1 year based on the movement of the sun in two ways, right? One is you can look at the cardinal points. I will take this point called the winter solstice, and you take that time or the day when the sun is in this position, and then approximately 1 year later he will come back nearby there. So you track when exactly the sun is going to come back to the same position, and that is one way of measuring the year, and we call that as the tropical year. Okay, and another way of measuring is as seen from the earth. You notice the position of the sun with respect to a background star, let us say S1, right? This could be, for example, Ashwini or something like that, any background star or nakshatra. Then roughly again 1 year later, the sun is going to come back into the same vicinity. Then you observe when the sun will be in the same position as you had noticed earlier with respect to the background star. Okay, and that will give you a sidereal year. Okay, so any questions here? So this is kind of important so that we understand further stuff. Okay,
So why is there a difference between the tropical year and sidereal year, sir?
I just now explained, right?
No, sir. Why is there a difference in the time? Like the tropical year is given as 365.2425, and the sidereal year is a little longer.
Yeah. Okay. Yeah. So why do you think they should be same, right? Why do you think they should be same? See, because we are defining it in different ways or measuring it in different ways. No.
Okay.
Right. So all it means is there is some relative motion happening between. So we have three systems here: the observer who's standing on the Earth, the sun which is moving or
Yes.
appears to move, and the background stars as the reference point. Right.
Yes.
So there is some relative motion which is happening here. Right. Some extra thing is happening here. That is
Okay.
why this time is different. Right. As simple as
Okay.
that.
Okay.
Yeah.
Thank you, sir.
Yeah. Okay. So continuing, as you have already noted, there is a difference, right? How much difference is this? Right? It's the difference in the second decimal point. Okay. So it turns out that this difference is actually about what is this? Yeah. So this sidereal year is going to be about 20 minutes longer than the tropical year, right? How do you get? You just take the difference, right? You get 0.01 something, multiply that with 24, right? 24 hours per day. And then multiply that with 60, you get the number of minutes, which is the difference between the 2 years. All right. Okay. So now let's come back to some more interesting stuff. So here, like we said yesterday, there are 4 cardinal points on the sun's path, which we called as the ecliptic, right? Winter solstice point, which is S4, right? This is the beginning of Uttarayana. This will happen typically on 21st December or in rare cases, 22nd December. Okay, summer solstice, again, point S2, right? This will happen on 21st June, which was recently, few years back, right? Declared as the International Day of Yoga as proposed by our Honorable Prime Minister, and almost all the countries have unanimously agreed, and then it has been running successfully for the past 4-5 years. Then we have the vernal equinox, which is at point S1, right? So this happens during spring in the northern hemisphere. That happens around 21st March. And then you have autumnal equinox, point S3, which happens during the autumnal season and falls on 21st September. So you can see here that between the two solstice points, you have exactly 6 months gap. And between the two equinox points, you have 6 months gap. And between the vernal equinox and the summer solstice, you have exactly 3 months gap. All right. Okay. Okay, so notice that this is something which I have spoken with respect to the Gregorian calendar. All right. So we'll come to that in a minute. Okay, but notice that all the cardinal points are falling on a constant date according to the Gregorian calendar. Okay, now let's come to this side, the sidereal year. And like we said yesterday, when I asked some people when we are going to celebrate Uttarayana, right? Some people said Makara Sankranti, 14th January. Some people said 14th April, and so on. So this is the detail here, right? So what does Makara Sankranti mean? Right, Makara is a Rashi, right? Again, this is a much later concept, but anyhow. So what happens when the sun enters the Makara Rashi? Okay, so there are 12 Rashis which are defined in the path of the ecliptic, right? In the sun's path called the ecliptic. So it is divided into 12 segments, and each of them you have a group of stars out there, and they are called as Rashis. And again, notice that this is much later concept. Okay, this is not a very old concept. So what happens when the sun enters this Makara Rashi, right, which will be somewhere here, probably somewhere here. Okay, so that will be called as Makara Sankranti. All right, and these days it is falling on 14th January. Okay, and somebody said the 14th April also. Yesterday the date was mentioned, so let me just clarify that it is Mesha Sankranti. So Mesha is another Rashi, right? It corresponds to Aries, and what the Westerners say. So there is another Rashi which is there, and then the sun entering that Rashi will be called as Mesha Sankranti, and that happens typically around 14th of April. Okay, so now coming to the more interesting stuff. Notice that the sidereal year is going to be 20 minutes longer than the tropical year. Okay, and the calendar which we typically follow these days, it's not Indian traditional calendar, but the one which is used for quote unquote official purposes, right? That is this particular January, February kind of calendar, which we formally call as Gregorian calendar. Why? I will come to it in a minute. Okay, so what happens? This sidereal year is 20 minutes longer than the tropical year, right? So can you tell me in how many years this 20 minutes will grow and become one full day? Right, for every year, this sidereal year is going to be 20 minutes longer. Okay, so how many years will this 20 minutes take to accumulate and become 24 hours, which is one day?
72 years.
Correct. Okay, so what happens? Oops. So after 72 years, okay, after 72 years, what will happen? This will shift to the next day. So after 72 years, Makara Sankranti will shift to 15th January. Okay, after another 72 years, it will shift to 16th January and keep going. Okay, and now we know, right? In our culture, I mean, at least today in common parlance, we tend to associate Makara Sankranti with Uttarayana. Correct? Most people would do that, right? So when you say 14th January as the date for winter solstice, right? We kind of associate that with Makara Sankranti. Okay, so there was a point in time when Makara Sankranti and Uttarayana, which is winter solstice, coincided. Okay, they were happening at the same day. All right, but that was some point in history, right? So can we calculate how many years back that would have happened? Right, so today we know winter solstice or Uttarayana starts on 21st December, but we are having Makara Sankranti. Let us take 14th January. So you have 9 days here in December and 14 days in January. So 14 plus 9 is 23, right? So if the Sankranti, Makara Sankranti has shifted by 23 days, how many years would it have taken? Correct, something like that. Yeah, 15 of the order of 1500.
Yeah.
Sir, a doubt, sir. Why does only it take 72 years, sir? Not lesser than that or more than that?
Oh, okay. Let me just clarify. See, this 20 minutes is only approximate number. Okay, 20 minutes, there is some 24.5 seconds or something. Just for ballpark numbers, I've taken 20 minutes. Okay, and for every year, the sidereal year is going to be 20 minutes longer. Okay, why? We'll come to that later. Okay. As time goes on, this 20 minutes will keep on accumulating. Okay, and it will become one day in 72 years. That is all.
Okay, thank you, sir.
So this is just simple arithmetic, right? Okay. Oh, why am I not getting the next slide? Okay. So then, so this Makara Sankranti, or for that matter, any Sankranti, will be shifting by 1 day every 72 years. So then, can you tell me what was the point in the nearest past when Makara Sankranti coincided with the winter solstice or the beginning of Uttarayana? Yeah. Oh, okay. You had already answered that. Sorry. Yeah. So you just multiply 23 and 72, right? And you get something around, 1500, 1600 years ago. All right. So roughly, this Makara Sankranti, or for that matter, any Sankranti, is going to shift by 1 month duration, right? Where in about 2000 years. Okay. So this is something important to remember. All right. So this is the reason why some people who criticize the Indian calendar, they rise up this point, right? Saying that we are celebrating the, Uttarayana in 14 January, whereas it has already happened on 21st December. And remember, yesterday I kind of mentioned to you, this is how I also got interested in this field, kind of. So therefore, that is what it is. Okay. All right. Okay. So then, what do you think? Which year should be following? Which calendar should be, or our calendar should be based on which year? What do you think? Right. So, for example, if you are talking about a calendar for tracking seasons, which year would be better? Going for the sidereal year or tropical year? Yeah, as people are saying in the chat window, tropical year is going to be better, right? Because during this point S4, this is where you are going to have peak winter. Whereas this Makara Sankranti will keep shifting all over the year, right? So this is in January, 2000 years later, it will be in February, again 2000 years later, it will be March, and so on and so forth. So it will keep going. Okay, so we have to be careful, right? So the another, on a lighter note, you can see that at least in South India, or at least in Karnataka where I live, right? So Makara Sankranti, people typically celebrate with til, that is the same, and good, that is jaggery, right? So these are good to have during the winter season. Okay. So somehow for this last 1500 years, somehow, although we have had great mathematicians, astronomers, somehow this correction factor has not been done. Somehow we have missed it. I don't know why, but so I think it's the onus is upon us to correct it in the future, right? Missing by 1 month is okay. But if we miss by too much, then it will be a problem. So at least every 2000 years, if we are able to make a correction, then we'll be fine. Okay, so maybe another 500 years later, what we can do is, instead of celebrating Makara Sankranti, we can just celebrate Dhanus Sankranti. Okay, that will be closer to the winter solstice point. So every 2000 years, we can just go back one Rashi and celebrate that Sankramana or Sankranti. Okay, that will be fine. So it needs a small correction every once in 2000 years. All right. Fine. Okay. So now, yeah, somebody is saying there is a doubt. Maybe you can just type in the chat window, right? Okay, so there is a one question. Let me just quickly see. Yeah, Uttarayana at 14 Jan, then Dakshinayan when it will come. Okay, so again, I was saying, right, Uttarayana is not 14 January. It's actually 21st December. Anyhow, Dakshinayana is this summer solstice point. 21st June is when Dakshinayana is going to begin. S2 you have here. Okay. All right. Okay, so there was one Pope, right? Vatican Pope, you may be aware. So there was one Pope named Pope Gregory. So somewhere in the 15th century, there was a lot of confusion in Europe among the calendrical systems which were in use. And he wanted to correctly set the date for Easter, because Easter was the biggest festival for Christians then. So he wanted to correctly set the date for Easter based on what they had discussed in what is known as the Nicene meeting. But anyway, let me not go into all those details. So what that Pope Gregory did, he sent a few people to India, supposedly, right? And then for studying the calendar and then to suggest the calendrical reforms. So till Pope Gregory was there, he took up this project. The calendar which was followed was called as the Julian calendar, based on Julius Caesar's name. Okay. So that time what they were doing, they just rounded off the tropical year to 365.25. Okay. And then they had put one leap year every 4 years. Okay, so that's what we usually think, right? But this Pope Gregory got this information that the average tropical year is 365.2425. So this is slightly less than 0.25. Okay, so you can just write it in this form, right? Tropical year with the average length of the tropical year. If you write it as 365.25, you will overestimate it. So you do a correction, right? Minus 3 times. This is just for convenience. I've written it in this form, right? Yeah. If you do this 0.25, you will have to subtract 0.0075, which I have written in this form. Okay. So now what happens if you put leap year every 4 years, right? Then again, you're going to have trouble. After hundreds of years, again, your calendar will go out of sync. Okay. So what this Pope Gregory said, he said, we will have the leap year once in 4 years. Okay. But with one correction. So what is that correction? So this 0.25 means you will have 1 day extra in 4 years. Correct. Okay. So that is fine. But then there is a minus. Okay. Minus 3, right? And what is this? Again, 0.25 means 1 in 4 years, or you can take this below and you can make it 1 by 400. Maybe that is simpler. Okay. So just make it 365.25 minus 3 by 400. Okay. It just means you have 1 leap year every 4 years. Okay. Or 1 extra day every 4 years. That is this. But you need to subtract, okay, 3 leap years or 3 days, either way, in 400 years. Okay, because this is 0.25 by 100, you can just think of it as 1 by 400. That is simpler. Okay, so every 400 years, remove 3 leap years or remove 3 extra days. Then what happens? Your average will be tracked. So every 400 years, you will be able to track this average. And this error will not accumulate. Every 400 years, you will be correcting it. Okay, so which 400 years to remove? I mean, which 3 years to remove in the 400? So this Gregory was somewhere there in the 16th century. So just for illustration, I will say 1600 will be a leap year. Okay. 1604 will be a leap year and so on. But what we will do, 1700 is not a leap year. Okay. Similarly, 1800 is not a leap year. 1900 is not a leap year. So in the 400-year period between 1600 to 1999, 3 leap years will be removed. Namely 1700, 1800, 1900. Okay, so this is the scheme presented by Pope Gregory. Of course, there could be other people assisting him. They would have done all the hard work, but this fellow would have put the chapa. That's how it typically works, right? Anyhow. But anyway, this goes in his name. So the calendar which we use today is called as the Gregorian calendar. Okay, so this is what he did. And what is the advantage of this calendar? Firstly, all the cardinal points, right? Summer solstice, winter solstice, equinoxes, they will all come on fixed dates as per this calendar. Okay, that is one. And secondly, the seasons will also be nicely tracked. Okay, so since you have S4 on 21st December, right? December, November, December, January, these will be the months when you have winter, right? And then March, April, May is the time you'll have summer. And then similarly, then you'll have the rainy season around June, July, and so on. And then S3 September, you have the winter and so on. So this calendar, right, based on the tropical year, will track the seasons. Okay. But there was another problem here. There was a religious problem, right? So this Pope, they sit in Vatican and they are followed by the Catholic people. But the Protestants, they had some differences and they had broken away. So the Protestant people did not agree to this calendar in the initial days itself. So there are various countries which adopted these reforms at various times. Okay, that is one. And secondly, if you notice, let us say these fellows began their calendar, let us say from, let's say 1 AD or 1 CE. Okay, so there would have been some 1500 years. Okay, so therefore then this error would have accumulated, right? So they would have had 3 extra days in 400 years, right? So what happens is roughly, if you take this Gregory in the 16th century, you would have had this 400-year period 4 times, right? 4 3s are 12. So around 12 days will be extra. Okay, so if you want to have this scheme, because remember, I said Pope Gregory was motivated to do this work in order to fix the date of Easter properly. All right. So he was bothered about 1500 year period or 1600 year period. So roughly, he had to deal with 4 periods of 400 years, which means 3 times 4, right, would have been 12 days extra. So what do you do with this 12 days extra? That was the question. So he said, just throw it away, right? For example, right? For example, although Pope Gregory gave this reform in somewhere in the 16th century, 1542 or something like that. As I said, various countries adopt this scheme at different points in time. Nobody or not all countries adopted it instantaneously. So, for example, Britain, which then was a Protestant country, adopted it in 1752, okay, around 200 years after Pope Gregory gave the reform. So, in September, they decided they will arbitrarily scrap how many days, right? After 2nd September, directly they will go to 14th September. Okay, so from 3 to 13, that is 11 days, they just scrapped. Okay, so if you just go back to your calendar app, whichever you have in your laptop or mobile, you just go back to this September 1752, you will notice that these 11 days are missing in the calendar. Okay, why? Because of this reform. Okay, and why only 11 days came? Because Pope Gregory, as I said, was interested from 1 AD or 1 CE up until his time and in future. Okay, but of course, the good thing is the seasons are fixed according to this calendar, and the solstice points are also fixed. Okay, but this calendar, as you know, is an arithmetic calendar, right? You just have the names of the months and then the number of days there are fixed. Okay, so you don't have to bother about any astronomy here, right? But in spite of that, you can see that the solstice points, the cardinal points are maintained as per the days, and the seasons are maintained. Okay, so maybe this is a good time to take a pause of 1 minute. If there are any clarifications, we can have. And let me see here. So what is the difference of Indian calendar and USA calendar? See, Britain colonized both India and US, no? So mostly whatever Indian so-called quote-unquote government official purposes, they're still using the British calendar only. And US also is similar. Okay, so there is no difference there. But cultural differences, we have many other calendars, many other epochs, right? So for them, it is only the Jesus, birth of Jesus, or is whatever. That was the epoch. But we have multiple epochs. We have Saptashi era, we have Yudhishthira era, we have Shalivahana, we have Vikramashaka, and so on and so forth. Okay, so that is only the epoch point. But even otherwise, we will, and Indian calendar is much more complicated than this Gregorian calendar, right? So Gregorian calendar, he just took one aspect. He just took what is the average tropical error, which, it is said that Indians helped him in getting this data. And he just had to do this fixation, that's it. So it was pretty simple. But Indian calendar, as we will see shortly, is much more complicated. Okay, so how can only simply throw 11 days from a calendar? Why not? They have done it, right? Every country has done it. Okay, is this accurate or approximate? Which one? Okay. Yeah. But notice that the winter solstice will be around 21st December. It can go 22nd December, but it will not move away. Right? That's like the Sankranti, every 72 years, it will keep on moving one day. Right? So every 2000 years later, this Sankranti will keep shifting by 1 month. Okay, so this will not be coordinated with the seasons. We have to do some corrections from time to time, and our ancients understood that you have to do the corrections because it is based on observation. So you have to keep observing, keep correcting. But somehow for the past few years, we have forgotten to correct it. Okay, fine. That is part of the reason also why we are discussing this today, right? So this needs some correction. Okay, so I guess with this we can proceed. Okay, so here let us just confirm our understanding. So here, so assume that you are on a point on the earth and then you draw the horizon, right? Horizon is what you are able to see when you stand on a point on earth. Then when the sun is at a point which is above the equinox point, okay, so this rising point on the horizon, rising of the sun, will be to the north of east, okay, as you can see here. And then as the day progresses, the sun will keep moving or seem to move apparently, and then trace this path. Okay, so this is during one day, right? So this is where we observe the sunrise, and this is where we observe the sunset. Okay, and if you are in the northern hemisphere, this will give you a long day, because as you can see here, the sun is above the horizon for a longer time compared to below the horizon. Okay, so below the horizon only this much, above the horizon is a longer time. Therefore, the length of the day is going to be longer in the northern hemisphere when the sun is above the equinox point. Okay, then similarly, at a later date, if the sun goes southward, right, during Dakshinayana, or when the sun is below the equinox point, you can just imagine another circle, right, at the boundary of this sphere, right? You can just imagine this way, right? So the rising point of the sun will be to the south of east, okay, and then keep moving, and then come back, and then a setting point will be again south of west, right? And then you complete the circle. Okay, so what happens? The sunrise will be at a later time, and the sunset will be at an earlier time. So the length of the day overall will be shorter than the length of the night during when the sun is below the equinox point in the northern hemisphere. Okay, so this path is called diurnal path. That is the apparent path taken by a celestial object as we see because of the rotation of the earth. Okay, so nothing new here, just to recollect and clarify. Okay. All right. So in the chat, if you have any questions, maybe you can be a little more precise, so that by reading the question, I'll be able to understand what it is, right? Some questions are really vague. Anyhow. Okay. All right. So we also began talking about the moon yesterday, and the moon, motion of the moon is much, much more complicated than that of the sun. So as I said, the moon takes on an average 27.3 days to complete one revolution around the earth. And our ancients knew that this number was between 27 and 28. So what they did, there were two traditions. One tradition identified 27 patterns of stars called nakshatra. Okay, so nakshatra, as I said yesterday also, nakshatra is not to be taken as a single star. It is a group of stars. For example, Kritika has 6 stars. Okay, so total among the 27 nakshatras, total number of stars is around 81. Okay, so nakshatra is a technical word, not to be used loosely. If you want to have an individual star, you can call Tara, maybe. Okay. All right. So therefore, there are 27 distinct patterns or regions which are identified to track the position of the moon as it revolves around the earth. Okay. Fine. And then in the olden days, people just went by the pattern. So all the patterns need not have had the same area or the same size. Okay, so some patterns could have been bigger, some could have been smaller. But over time, once the mathematical techniques got better and better, people said, you don't have to keep observing always. Just by doing mathematical calculations also, we can do our calculations, do our tracking. Okay, at that time, when the mathematical astronomy became more popular, that time, these 27 nakshatras were translated into a mathematical concept where they made the area equal. Okay, so they took a 360 degree for the circle, right? Divided that by 27, so you get around 13 degree 20 minute, and that was assigned to each nakshatra. Okay, that was a later development where the mathematical techniques were improved. But we should not forget our roots, right? So the nakshatras have a distinct pattern which can still be observed. Okay, so that is that. So that is the reason you have 27 nakshatras, of course. So later on, people understood that this the average period of revolution of the moon is closer to 27 than 28. So the 27 tradition, the tradition which identified 27 nakshatras became more popular, and that is what is mostly followed today. Okay. Okay, fine. All right. So we have spoken about a year. Now we have to talk about a month, right? And as you can expect, in all languages, the word for month and the word for moon are very, very nearby, connected. For example, in English, right, you have moon and month. Okay. So if you take in Sanskritam, for example, you have Chandrama for moon and Masa, okay, for a month. Okay, similarly in South Indian languages, in Kannada, for example, we say Tingadu for month, and that is also connected to the moon. Okay. All right, so let us see how we are going to define a month based on the moon. Okay, so as we know, the moon takes only about 27.3 days to complete one revolution around the earth, whereas the sun takes 1 year. Okay, so and our ancients did one more small approximation. They said, let us take the number of days in a year to be 360 instead of 365, right? Since 360 is a whole number, you can work with it. Of course, there will be errors, which we will point out shortly. So what happens? So you take 1 year to be 360 days, right? So the sun will take approximately 360 days to complete one revolution, right? And it is because of this that some people opine that a circle is said to have 360 degrees, right? Because our people approximated the number of days in a year as 360. All right. So roughly you can think that the sun is going to move 1 degree per day, okay, in its revolution around the earth. All right. So can you tell me how many degrees will the moon move in 1 day? Anyone listening? You can just type in the chat window, or if you have access to the mic, you can just say it. 24 degrees. How do you get 24? Right. I said the moon will take about 27.3 days to return back to the starting position, completing one revolution. And then you have 360 degrees. Right. So you have to do 360 divided by 27.3. Okay, can you repeat? Okay, so the moon takes about 27.3 days to complete one revolution around the earth. Okay, and so if you take 360 degrees as the angle of the circle, right? How many degrees will the moon move per day? As people are saying, it's slightly more than 13 degree, correct?
13.34, sir.
Yeah, 13 degree, 20 minute.
Yeah.
Okay, roughly. If you take it as 27, you get that anyhow.
Sir, I took 27.
All right. Okay, great. So now think about this. Okay. So now the earth is here. Okay. The moon and the sun are like this, right? So as you know, the moon does not have light of its own. It's only going to reflect the light of the sun. As you see from the earth, if the moon and the sun, right, are aligned in this fashion, are at the same angle, right, then the light reflected by the moon will be transmitted away from the earth, right? From, if you look from the earth, we will see only the dark side of the moon. We will not be able to see the bright side of the moon. Okay. So since we are not, so the moon will not be a shining object in the sky. Okay. So this we will call as new moon. Okay. And literally, I don't know why they call it new moon, because it should have been no moon actually instead of new moon anyhow. But we call it as Amavasya. Okay. In Sanskrit, this has a very nice meaning. Ama means close by. Okay. So here, if you see, as I said, we don't have a nice way of getting the distance, right? And if you see, for an observer looking from Earth, the sun and the moon will appear to be of the same size also. Okay. So therefore, now today we know that the moon is much closer to Earth than the sun. That's okay. But in the olden days, it was not easy to know that. So our ancients thought that the moon and the sun are together. Okay, that is why Ama means together. Okay, Amatya also you would have heard, right, for a minister. So the minister is supposed to be close to the king and then advise on all critical matters. So that is the reason Ama means nearby or close by or together. Okay, Amavasya. Okay, Vasya is something to stay together, stay close by, that kind of thing. So that is when you have this Amavasya, loosely translated as new moon. All right. Okay, that is one. So when both the sun and the moon are at 0 degrees with this reference point from the earth. Correct. As somebody is pointing out in the chat, yes, the sun and the moon will also rise together and set together during the new moon day. Correct. Okay, so as time goes by, then as you can see, the moon will move faster than the sun, right? As you rightly pointed out, the moon will move about 13 degree every day, whereas the sun is moving only 1 degree per day. All right. So after about when the moon completes half the revolution, right, he'll come here, right, and the sun would not have moved that much, right? So we can say that the sun and the moon will be diametrically opposite. Okay. So now we will be able to see the lit face of the moon, right? So the light reflected by the moon will reach us on Earth as observers, and we will be able to see a bright moon. So this will be the full moon for us. Okay, now, okay, starting from this position, after about 27.3 days, right, the moon will come back to this position, okay, which I call M1 here. Okay, how many days it will take? Let us say 27 days. Okay, so after 27 days, will I have the new moon or Amavasya?
Yes, sir.
Huh?
Yes, you will have the new moon after 27 days.
Acha. Okay, then you have not listened properly or you have not paid attention.
Should
Right?
not be, sir.
Why? Okay.
Because sun has moved his position.
It's okay. All right. Why? Because the moon would have taken 27 days to come back to the starting point called M1. Right? In this 27 days, the sun would have also moved 27 degrees. Right? Are you able to see that? Yeah. The sun would also have moved 27 degrees and the moon is roughly moving 13 degrees per day. Okay, so the moon will take roughly 2 more days, right, to catch up with the sun. Okay. All right. Are you following this? So the
Yes,
average
sir.
duration,
Yes.
the average duration between two new moons will be about 2 days more than the time period of revolution of the moon. Okay, so this is another important concept to note. Okay, fine. Let me just okay, so this is how you have the various phases of the moon as we see, right? So this is the Amavasya, right, or the new moon. Actually, according to me, this is what should be called as new moon, right? More than this is no moon. This should be new moon, right? Even it has happened in our culture also. So the word which we use for new moon is actually darsha. Darsha means something which is seen. Okay, but that has been collapsed to new moon. I think it should be in the first day after new moon, after the so-called new moon. Right? Anyhow, that's okay. Anyway, that has happened. So what happens? So if you define your month, you can define your month now based on new moon to new moon or full moon to full moon. Okay, that's what happened. Right, you can either go from new moon to new moon as 1 month or full moon to full moon, and we have both traditions. One is called Amanta, another is called Purnimanta. All right. Okay, so let us take Amanta for example. So we start with the new moon or Amavasya, and then slowly what happens? The angle between the sun and the moon will slowly keep on increasing. Right, Amavasya, notice the angle is 0. The angle will keep on increasing. Then we will see that the lit phase of the moon is increasing in area. All right. Okay. Fine. That is one. And then, so this will keep on increasing till we get the full moon. After that, again, so this will start waning. So this is called waxing and this is called waning. So if you go from full moon, then the next day, again, the angle is going to reduce. So here the sun and moon are diametrically opposite. Then the, so angle is 180 degree. Then the angle is going to keep on reducing progressively till you hit the new moon. Okay. And roughly, the average period between 2 new moons or 2 full moons is going to be 29.5 days. As we said, it's roughly 2 days more than the time period of the revolution of the moon. So this is roughly 29.5 days. Okay. So what our ancients did, again, dealing with these fractions is kind of hard. So they round it up to 30. Okay, 30 days. Okay, of course, there is a rounding error. We will take care of it later. So we will round it 29.5 to 30. Okay, and then divide into 2 halves, right? 15 when the moon is waxing, that is increasing in the area of the lit surface, and 15 waning, where the lit area of the moon is going to reduce. Okay, so that is what we have. Okay, why am I facing problem in changing my slide? Okay, so here, as we said, the angle is 0. So that is when you have Amavasya, and then the angle keeps on increasing, angle between the sun and the moon keep on increasing. Then you have more of the lit phase of the moon will be visible from Earth. Okay, so when that area is growing, we call it as Shukla Paksha. Shukla is bright. Okay, so that is when the area of the lit moon visible to us from the Earth, that will keep increasing. Okay, so that is called Shukla Paksha. That will be 15 days roughly, or at least 15 tithis. Okay, then at the end of the Shukla Paksha, you have the Purnima or the full moon day. Then after that, the lit face, the area of the lit face of the moon visible to us from Earth will keep on reducing. That we will call as Krishna Paksha. Okay, Krishna, as you know, I guess, is dark. Okay, Paksha means a side. It can mean a wing also, but anyhow, 2 parts you can think of it. Fine. I think this is another important concept which needs to be understood. So just pause for 1 minute here. If you have any questions, you're most welcome. So I'm having some difficulty in changing my slides. All right. Any questions here so far? Okay, so if there are no questions, we'll proceed. Now let us take stock of what all we have discussed so far, right? So we said 1 year will be called a Samvatsara in Sanskrit and many other Indian languages. That is divided into 2 ayanas. Okay, so ayana is essentially the motion of the sun, right? So Uttarayana and Dakshinayana. Uttarayana is when the sun is moving towards the northern direction, and Dakshinayana is when the sun is moving in the southern direction. Okay, then why am I having so much difficulty? Okay, then another classification is seasons, right? In 1 year, our ancestors have identified 6 seasons. As I mentioned yesterday, the seasons are much older than the months themselves. Okay, the names of the months have changed over the years, but the seasons names have remained the same. Okay. All right. Okay. And among these seasons, the names are, right, Vasanta, Grishma, Varsha, Sharad, Hemanta, and Shishira. Okay. And here, I would like to mention one cultural point. See, Varsha is the rainy season. That is one of the very beautiful seasons. Okay, so the Varsha Ritu itself is taken as a proxy for the entire season. Right? In many languages, Varsha itself means a year. Right? But here, Varsha means the rainy season. Similarly, the Sharad Ritu is also very beautiful because after the rainy season, all the clouds would have rained and then the sky will be clear. Okay, so the sky, you can watch it in a very beautiful manner. And also the weather would have become pleasant, right? It's not hot summer anymore. It is not rainy, right? So when it is rainy, you have all the marshy places. It's difficult to move around. But in Sharat, the rains have gone and then relatively dry weather, cool weather. So it's one of the most beautiful seasons. And since the sky will also be not having clouds, you will be able to observe the stars and especially the moon very, very nicely. That is why some people keep their names also as Sharat Chandra. So that very beautifully you will be able to see without any obstruction. Similarly, Vasanta is also a very beautiful season. Here you have all the flowers and the new sprouts, coming up. So sometimes the Sharat and Vasanta are also taken as proxy for the year itself, right? For example, there are many prayers you would have come across, right? Jivema Sharadashyatam, Nandama Sharadashyatam, and so on. May we live 1,000 Sharads. Right? Or some people, you can say he's celebrating his 60th birthday. Instead of saying that, you can also say he has seen 60 Vasantas, right? Something like that. Typically, these 3 are taken because they are the most beautiful ones, right? Grishma, it's very hot, right? Not very comfortable. Hemanta and Shishira are kind of freezing months. So that is also not very pleasant. Okay, the other 3 ones are very beautiful and also enjoyable. All right. I'm having too much trouble in changing my slides today. Okay. And then one masa again we defined, right? So this is defined from either Amavasya to Amavasya or Purnima to Purnima. And that we divided into 2 pakshas, 2 parts, 2 fortnights. One is called as the Shukla Paksha, another is the Krishna Paksha. Shukla Paksha where the moon is waxing and Krishna Paksha where it is waning. And then one Paksha has 15 tithis, right? And these tithis, in the olden days, they were given different names. Madhu, Madhava, some names were given. But these days, just they are identified by the number, Prathama, Dvitiya, Tritiya, and so on. And then 27 nakshatras also we saw, and there is some question in the chat window saying, Am I saying that 81 stars will form one nakshatra? No, I'm not saying that. Among the 27 nakshatras, there are a total of 81 stars, roughly. And different nakshatras have different number of stars. For example, Kritika has 6 stars. Okay. Now, based on all these concepts which we have discussed, the Indian calendar, typically known as Panchanga, right? Here itself you have in the name itself, Pancha Anga. Right? Pancha means 5, Anga means part. Okay, so let me just list out what are the various angas of this Panchanga. As you know, Vasara is the weekday. In some languages, it's also called Vara, like Somvar, Mangalvar, etc. or Somavara, Mangalavara, etc. In Sanskrit, typically they use Vasara, Soma Vasara, etc. Okay, and then what is the next one? Which anga is next? What is this? Tithi, right? Tithi already we have discussed. So how do you define one Tithi actually? You can come up with, yeah, what is this? Maybe alt key is sticky, huh? Maybe, I don't know what has happened. Okay, so yeah, so Tithi, right? So Tithi you can define mathematically also, right? One Tithi, so you have 15 Tithis. Let me just try. Yeah, so 15 Tithis, right? So 15 Tithis are there. In one angle of 180 degrees, you have 15 Tithis, right? This is the angle between the sun and the moon, okay? So you have 180 degrees here and you have to divide that into 15, right? 180 by 15 will be 12. So one Tithi you can define as the duration or the time it takes for the moon to lead the sun by 12 degrees. Okay, so that way you can define Tithi mathematically. All right, so that is Tithi. And Nakshatra we have already discussed, right? So there are 27 Nakshatras. And okay, there's one question in the chat window. How many years calendar repeats? Okay, we'll come to that. Okay, so Nakshatra, Tithi. Then there are other two, Yoga and Karana, which are not very important astronomically. They are there just for providing some redundancy, right? Whenever you are making any calculation, if there is some redundancy, you'll be able to quickly check whether you have made any error or you are doing it right. Okay, so let me not discuss what they are, but Tithi and Nakshatra are most important because they have direct link with astronomical observations, right? Tithi gives you the angle between the sun and the moon, and Nakshatra gives you the position of the moon with respect to the background stars. All right. And Vasara is something, it is the 7-day week, right? And it is a much later concept. Okay, the 7-day week, we do not find in the Ramayana, we do not find in the Mahabharata. It is not there even in any of the Kalidasa's works. Of course, forget about being in the Veda. All right. So it is a much later concept. So we don't know how it came in because it also does not have any astronomical connection. There is no observable. For example, see, if you have a doubt whether today is a full moon or a new moon, right? You can just go in the evening and then you can observe the sky and you will be able to confirm, right? But suppose you get a doubt that today is Thursday or not, right? How will you verify? Right? There is no astronomical phenomenon by which you will be able to determine that today is Thursday. It's completely arbitrary. Okay, and there are, of course, there is some logic why it is there, but we have not completely understood it. But whatever logic is there, that is definitely not tied with observational astronomy. Okay, that much we can be sure. So therefore, it is not there in the ancient works. It's only modern. So for example, the 7-day week, at least in India, has come only after Kalidasa's time. Okay, so probably around 1,500 years old, not more than that. Okay, so maybe here I will just take a pause for 1 minute and then try to read some questions in the chat window. What is the reason for having 32 months, 32 days in some months in the Malayalam calendar? Okay, that is because we are talking about the averages here, right? So when you are talking about averages, sometimes you will have more, sometimes you will have less. Okay, why will you have more and less? That is because we are talking, so we are here thinking of these as circles. One thing is they need not be circles. If there are ellipses, then you will find that the velocity, instantaneous velocity will be fast during certain times, it will be slow during other times. Okay, so for example, you can have more months if in the Malayalam calendar, okay, Malayalam calendar uses the Sauramana, so that is based solely on the sun. So if the sun is spending more time in a particular Rashi during a certain time, then you will have more days there. That is all. Okay, and we are talking about averages. So once in a while, you can have one day more, one day less here and there. You can close that browser tab. Which is browser tab? Not required. Okay. Oops, what is happening? Okay. All right. Fine. So let me continue. Let us take a couple of examples from literature, right? So you have had a couple of sessions on the Ramayana. So can you tell me what was the, when did Rama's birth happen, right? According to the calendar which we have discussed. Of course, Vara, I said, is a later concept, so we'll not be able to tell which day of the week Rama was born. So that concept itself was not there. But Tithi Nakshatra will be able to tell. Yoga Karana, I'm not interested. Masa, of course, we are interested because we need to celebrate, right, every year. Paksha, of course, will be interested. Okay, so can someone tell me about Shri Ram? What is the birth date? Oops, this is not really big. January 10th, no, that is wrong. Okay, so maybe you don't remember. So it's in Chaitra Masa, Shukla Paksha, Navami, and Punarvasu is the nakshatra. Okay, so the moon was in the Punarvasu constellation. Then, how about Sri Krishna in the Mahabharata? Janmashtami? Anybody? It's become hard now for me to see the chant. September, Bhadrapada Ashtami, no, that is not correct. Yeah, Shravana Masa, Krishna Paksha, correct. Rohini Nakshatra, that is correct. Yes. Yeah, Shravana Masa, Krishna Paksha, Ashtami, Rohini Nakshatra, correct. Okay, so here there is an interesting concept which is there in our culture, but somehow it is not completely understood. At least I have not understood it completely. Anyhow, I'll just present it and then we can discuss what. Hello? All right. So we have this concept called as Deva Pitra Rishi. Okay. So we have discussed one Samvatsara divided into two Ayanas, right? And Uttarayanam is called as the day of the Devas, right? Remember, Uttarayanam is the period when the day of the duration of the day is progressively increasing. Okay. So that is called as the day of the Devas. Of course, you can ask who are Devas. I don't know honestly, but this is the concept which is there. Dakshinayana is the night for the Devas. Okay. During Dakshinayana, what happens? The duration of the day is progressively reducing. Okay, so similarly, we have Pitrus. Shukla Paksha is said to be the day for the Pitrus. Here again, Shukla Paksha, remember, is the fortnight where the bright side of the moon visible to us from the earth will be increasing in area or size. Okay, that is called as the day of the Pitrus. And then Krishna Paksha will be the night of Pitrus. Again, who are the Pitrus? I'm not very sure. Maybe they are ancestors. I don't know. Okay, so with this, the reason I presented it, although I don't understand this much, is because there is a beautiful imagery here connected with Shri Krishna especially, and you can also extend it to Ram if you will. Okay, and of course, another thing I have not mentioned here, which I didn't mention yesterday, also very basic concept. Why do we have day and night for us humans or rishis here? Right, because of the rotation of the earth. That's it. Right, because of the rotation of the earth, the sun appears to rise in the east and appears to set in the west, thereby causing day and night for us humans on earth. Okay, now with this, let us just analyze these two examples which I have brought. Okay, and there are only 2 minutes to go to 1 o'clock. Anyhow, we'll have one more session after lunch, so let us see. Okay, so now, so can you tell me, Chaitra Masa, will it occur in Uttarayana or Dakshinayana? Yeah, if you are quick, it will help because I want to kind of cover this before lunch. Chaitra Masa, right? Chaitra is Vasanta Ritu.
Dakshinayana.
No, it's in Uttarayana. Okay, so Uttarayana, this Chaitra Masa will occur in Uttarayana, so it is the day of the Devas. Then so the Rama's birth happened in Shukla Paksha, so again the day of the Pitris. Okay, and then it is said that Sri Ram was born around the noon time in the Abhijan Muhurta. So it was in the time during the day of the people as well. And as you know, he was born in the palace, right? And he was born as the eldest child to his parents. And his parents also perform, that is Dasharatha performs Ashwamedha and Putra Kameshti to beget Ramachandra. Okay, so that much is well known. Now come to Krishna's story, right? Very interesting. So Shravana Masa, can you tell me whether it occurs in Uttarayana or Dakshinayana? When do you get Janmashtami? Is it after 21st June or before 21st June? Roughly. Sorry? Okay, so I'm running out of time, so I can't wait too much, right? So this is during Dakshinayana. Okay, so Shravana Masa will occur during Dakshinayana. It is the night of the Devas. Okay, and in Krishna Paksha, as you have rightly said, that is the night of the Pitrus as well. And he was born during the night, right? So that is the night for the rishis or the humans. And he's born in the prison, jail, right? You can see the contrast. At every step, you can see the contrast between Rama and Krishna, right? And he's born in the Rohini Nakshatra, of course. And then he's born in the prison, right? And his uncle is waiting to finish him off. And he's the last child of his parents. Okay, and Kamsa is waiting, right, to finish him off as soon as he's born. So there's a knife which is hanging on his neck. That is one. And secondly, as you may have seen the Mahabharata serial, it is raining heavily outside also, right? So there's no chance of even lighting a torch. In those days, lighting a torch would mean that you dip a cloth in some fuel, which is combustible, and then wrap it around a piece of a log of wood or something, light it, and then you can use it, right? So that would be what you would call as a torch around 5,000 years ago. But it is raining so heavily that even that torch will not be able to help. Okay. So utter darkness, utter hopeless situation, right? So again, I'll repeat, it is the night of the Devas, night of the Pitrus, night for the humans. He's in the prison, uncle waiting to finish him off, and raining heavily outside. So you can't even use a torch, and it is raining so heavily, it's difficult to even walk around or go around, right? Outside. Okay, so, and then at birth, as you know the story, he's immediately separated from his parents. He has to grow up away from his parents right from day one, right from the day of his birth, right? And in spite of all this, so much difficulty, and he's born in such a hopeless situation, but then he guides humanity. He becomes the light for entire India. And in spite of having to go through so much difficulty, have you ever seen Krishna complain, right? Saying, I was at my birth itself, I was separated from my parents. I was born in prison, right? Do you see him with such a crying face complaining to anyone, right? We can't even imagine, right? So that is how these great people have, inspired us through their lives, and that is how they are, surviving amongst us even after 5,000 years. All right. I guess with that we can take a break for lunch, and then we'll come back and then continue.
Yes, Dr. Rajat, though a series of hands are risen, yet I think we better give participants a time to have their lunch in peace so that we can meet again at 2. So dear participants, we have Dr. Rajat again with us at 2. So we can have questions at that time. Okay. So from 1 to 2 is the time for lunch. And at 2, we'll meet again with Dr. Rajat. And another thing that I would like to share with all of you is that at 4:30, we have the former General Council member, MBA, Professor S.K. Kark, who's also been a former Vice Chancellor, Chaudhry Charan Singh University, MMT and MMTU. So presently a member of 3 important national committees of AICTE, evaluation of educational outcomes in which ministry and Stanford University are involved. One related to NEET as well, NEAT. Okay. So Professor Kak is going to be with us, and he's going to interact with all the participants and students in special. And tomorrow there'll be a local site visit online, and that will be at 10:45. So as Ellora Caves as World Heritage Destination, we'll have a view of that too. So with these words, of course, I would like to thank Dr. Rajat for a very, very intricate, very interesting session. And we'll be meeting again at 2, and we'll be having a session with Dr. Rajat again. So with these words, of course, I thank Dr. Rajat, and I request RP Bhaiya to please close the session for a break of 1 hour. Thank you so much, sir. This was a lot of interest in amongst children also. They have their hands risen, but we'll take up the question in the afternoon session.